Welcome to this episode of DIY3DTech.com. In this episode of the MicroMill project, what I want to do is disassemble it all, clean it, get some of that Chinese oil off. You can kind of see it's bit over everything, and kind of share with you what this looks like in its pieces. So if you're interested in doing the same, you might want to follow along. So all in all, it's a pretty interesting build. Most of it is built around these cleats, sort of like T-nuts that mount into all the tracks and stuff like that, and all of it goes together with that. Now, one of the things I was a little bit concerned when I first got this and was playing around with it, that there was a lot of backlash in it. However, upon disassembling it, what I determined is the majority of the backlash was actually in these adjustment screws, because what happens is these are D-shaped, and the D-shaped rod goes into here, and there was a lot of slop between the rod and the actual knob, and that's where basically a lot of the slop was, because fortunately there's actually a brass anti-backlash nut inside here. So by no means is this going to be perfect, or are we going to create aerospace parts, maybe some aerospace parts for some RC models or something. But you know, the tolerances, you have to kind of expect what are you going to get for, you know, 200 bucks really. But it really is turning out to be a really fun project. Now, a couple things that I discovered in the disassembly process: all of this is managed sort of by a thrust washer system. So in other words, when you move a piece, it has to have 2 points of pressure. One is here, which moves against the block, and then one has to be on the other side, or it thrusts against this washer. And actually it's the tensioning of this against it, and as I mentioned, there was a lot of backlash because of the lack of tensioning, and also the machining of these against this face. So what I'm going to have to do in my conversion process is source some 4mm thrust bearings to go on here. I've never found any that small. I've never really looked for any 4mm. For the Probotics Fireball, I actually got some. Those were much bigger thrust bearings. And what a thrust bearing is it's a bearing that goes in between the thrust washer, and the pressure is horizontal rather than around. Let's see if I can't do an overlay to give you an idea what a thrust bearing is. So I'm going to see if I can source that. Even if I have to go with a little bigger one, I think that's okay, because then what I'll do is I just machine an insert to manage that larger thrust bearing. But that's pretty much what my plan is with this. Now, what I need to do is mate up the stepper motor with these. Now, one of the other challenges I'm going to face is the distance. So as you can see, you know, here's the shoulder on this rod. And basically all of them are the same, because all of them have the same type of knob assembly. So you have all this space going all the way through for this. So you see, you got a lot of space. So what will happen is I'll have to actually connect the motor quite a ways out. You know, so I'll have basically from my shoulder all the way to my motor. So my coupler is going to be fair sized. I'm going to have to handle the torque. Now, I haven't quite decided how I'm going to manage this. I had originally thought about machining some standoffs that would recess in here, allow a bolt to pass through, and then mount to a motor housing, or, you know, motor plate out here. And so this would actually attach something like this and have a motor plate. I think I'm still going to do something like that, not sure. Or just remachine a whole new plate to go on there. One half dozen there. I'm still working on some designs. I haven't worked that all out yet, because I wanted to get it apart and see what I have to work with. Now, one of the pieces on the Y, the Y is held in by some of these kind of self-tapping, almost wood, you know, they're machine screws, but you know, it's not threaded into the axis. So what I'm going to have to do is probably see if I can't tap that out to receive some like M4s or M5s or something like that to hold this in. And this piece, again, very similar to these. Remember, the Z-axis and the X-axis are exactly alike. All axes are the same as far as the rod, just length difference. Matter of fact, the Z and the X are the same assembly. It's just a Y that's a little bit different. But again, here I can, again, I'm thinking about doing the stanchions here, standing it off, having the motor mount bracket out here, and then just tap it for extra rigidity to do that. So I don't think this is going to be too big of a problem to do. Again, so first on my list, source the thrust bearings. Second is I will have to machine some sort of coupler. I'm going to look, but I think I'm going to have to do the coupler myself. And then I'm going to have to do plate and standoff. So I think I'm just going to take a standard NEMA 23, sorry, NEMA 17. These are 17s, I believe. So I think I'm just going to take a standard NEMA plate and then build it up in CAD to kind of receive it. Now, it's not going to be taking a lot of torque, so I think 2 strong stanchions should be enough to hold it. I'm not going to be doing anything too crazy because I mean the motor is, you know, only a 36 watt motor, so it's 36 12 volt 3 amp. So anyway, so far I'm pretty excited about this build, so hopefully you guys are excited. You know, if you've done one like this or you've worked on this mill before, hit me up in the comments below what you've done, because I'm going to do this in pretty much real time as you're seeing these videos. So, and again, what I'm going to do is actually use this newer version control board, which I'll talk about in a future video, to actually control everything on this assembly. And what I'll do is I'm going to make a mounting to go on the back side of this to mount this, and I'm going to actually probably see if I can't steal some of the power that goes to this. I'm not sure how big the power supply is, or since this is 12 volts, just get a bigger 12 volt power supply and power the whole shebang with this. So again, I'm pretty excited about this project, moving it forward, see some lathe work, some CNC work, and hopefully I have a pretty cool project. Now this is like more like a TAG, or I'm not sure how you pronounce it, or a shoreline. But you know, for again, I'll probably have 300 bucks, maybe 3 1/4 into this whole thing by the time buying this assembly, buying the stepper motors. Technically I have the stepper motors and the controller. Should put me under 3 1/2 for it. What I'm hoping is going to be a rather usable MicroMill. So I think this would be okay for circuit boards. I think this would be okay for small milling projects. The milling vise is really kind of cute, and it actually can go up to a far bigger surface, you know, because here's the bed and it's got dovetails in the bed, so we can do quite a bit there. And it does have a pretty good Y motion here, so I think it'll be an interesting project. So anyways, I wanted to share this with you guys disassembled so you can see the pieces. So if you've been thinking about it, you don't have to guess. You can see all the pieces here, how it comes apart, how it goes together, how it all works. And if you want to tackle this, I think for the money, it's a good base. Oh, it runs, you know, an atypical of most slides in that it has these adjustments in here with this, what I would call a Teflon or high density plastic that it all slides upon. So it's actually not too bad. So you can actually adjust some of the tolerances and backlash. Again, you're not going to design aerospace parts with this, but it's super fun project. And if you're looking for a useful little mini mill, I think this, or actually MicroMill, I think this is it. So anyways, Swag Shop's going to be up in the corner. Don't forget to subscribe, hit the bell button, and hey, we'll catch you in the next video where we do some more with the MicroMill. Cheers.
Please click like below and subscribe to the channel.